So let's take a look at like what the derivative is really telling us in a function. And we're going to look at it right now as instantaneous rate of change, also known as the slope of the tangent line at a point on the curve. Okay, so the original curve, or the original f of x that we're looking at, is x cubed minus 2x squared plus 3. You can see that graphed here in blue. Okay, so the green line here is the tangent line, meaning it touches at one point, and it's going to be touching at a point on the curve. Now, if you notice here, this is the x value of the point on the curve, and then this 5.12 is the actual derivative when you input negative 0.8 for x in the derivative. Okay, the derivative of this, if you just look at the power rule, would be 3x squared minus 4x. The 3 would go away. And that means when you put in negative 0.8 into the derivative, you would get this value. Well, what does that value tell us? That value is telling us how fast is the y value going up, in this case because it's positive, with respect to the original f of x, right? So let's look at what happens when we move the point along the curve. Okay, so right now it's going up at a rate of 5.12. And as we move it along, right, if I move this point along, now it's getting smaller, right? 3.4, now it's under 3. And as I get close to this high point on the graph, notice what's happening. It's getting, now it's 2, now it's below 2, and it's going to go all the way to, let's see if I can get it exact, it goes to 0. Okay, and the reason why it's 0 is because the rate of change, or the instantaneous rate of change here, it's not going up or down, right? It's at a high point, so that's why it's 0. Okay, so now let's keep going. All right, now if I go here, now our derivative is going to be negative, right? Because as I put these points in, 0.5456, I actually get a negative number because it's decreasing. Okay, so when the graph is decreasing, your derivative is going to give you a negative output. And then notice what happens again here. We got a low point here, and we're going to, let's see if I can get it exact. Well, we can't get it exact, but you can see it changes from negative to positive right here. Okay, so we hit that low point. Technically, there is a 0 there, but we'd have to calculate it. And then we start going up again. Okay, so now my rate of change, which is really the derivative, the slope of this tangent line starts going up. Here at 2, you can see it's 4, right? And then it just keeps going up, and it's going to get higher and higher because it's going to go up at a faster and faster rate. So that's what the derivative is. It's the slope of the tangent line at a point, or how fast the y values are going up or down, or how fast a graph is going up or down. That's what the derivative is telling you.